Hello everyone, here is the web app that we have created to visualize the results after applying pre-processing and augmentation techniques. Those are typically observed in machine learning applications. So here data can be any of these four formats: text, audio, image or 3D geometry. So here on the left hand side we can see there is a panel to upload the data type. So out of these four data types we can select any of the one. So let's say we will start with the text file. So here we click on the choose file and then we can see only the text files available here. We select open and then we select upload. So here is the whatever is the content is available in the text file gets displayed here. So there are different pre-processing and augmentation techniques which are available specifically for text files. Those are visible here. So here is the padding, the remove punctuation, tokenization, embeddings, synonym replacement and random insertion. So what are these techniques? So here the brief description can be observed with the help of tooltip. So once we hover over it, so brief description appears here what this each of that technique does. So let's say we go to the tokenize. It tokenizes text using BERT tokenizer. So let's say we will select that option and we will select apply. So whatever is the result of the this particular pre-processing technique appears here. So there are different words separated out as a token according to this particular BERT tokenizer. So here the whatever is the effect is applied pre-processing tokenization, that name is visible here. So similarly we can apply different other techniques as well. Let's say we apply the embeddings and there are certain embeddings those appear for the different tokens, those are that we saw earlier. So let's say we apply synonym replacement, then there are certain words from this particular original text, those get replaced within the new those get replaced and the new text is visible here. We can scroll down up and see, and here is similarly random insertion we can apply. So let's say we go to the next data type, audio. We choose file. So here the only audio we can select here right now. So let's say we'll select a sample data, and here is how the data appears here. We can play the data, and then there are preprocessing and augmentation available specifically for audio will be available here on the left hand side, and along with their explanation that we can see here. So let's say we'll select right now MFCC and sorry, I think I uploaded again. So we'll select the MFCC again, we'll select the apply. So whatever is the MFCC spectrogram for that particular audio is visible here. And let's say we apply time stretch in one of the augmentation techniques, and then we click apply. So original audio was 18 seconds. Now after post processing 15 seconds audio is visible, and we can play and listen to this particular audio. Similarly we will go to the image. We'll choose the select image file. We'll select the only image file we can select now, and we select this particular image. We say upload, and this is the image that is available. And then there are resizing, grayscale, and then the flip and all those techniques which are available. So let's say we will select resize, and then resized image into the typically 224 by 224 pixel is available here. The original size is 1280 and 852 pixel. And let's say we can apply grayscale as well, and let's say we apply rotation as well. So randomly rotated according to image up to 30 degrees using PyTorch. This particular description is available. So let's next option is 3D geometry that we can select. So let's say we select in this particular case a simple cube is selected that is axis aligned, and we are seeing only x and y axis. So that's why it appears as if it is 2D image. And there are, with respect to 3D geometry, there are different pre-processing and augmentation techniques available. Let's say we apply right now, it is centered around here, so that may not be visible. Let's say we select normalize, then the size changes, the overall geometry gets confined into unit sphere here. So let's say we apply a random rotation here again, Now we can see the originally axis aligned box is randomly rotated and its x and y projection is visible here. And we can do a random scaling as well. It gets randomly scaled into along the whatever the original directions those are available. And we can say add noise as well, where the vertices get shifted by small distances from their original position. So this is the overall app, and the code which we are following to do this is available here, where we are handling the backend of this particular application in the main.py. It is handled by a FastAPI, and there is a front end which has CSS, HTML, and JavaScript files which are present in this particular folder, app folder. And there are utility functions which do the data processing, uploading, data processing. Those functions are available in the augmentation, preprocessing, and utility. And there are different requirements for this particular repository. Those are available here in the requirements.txt. So here is the overview of this particular app, and then there are different features those are available into this particular app. Those are all outlined here. And overall architecture, the backend, FastAPI, front end, utility functions, and the configuration that we already saw, and the installation procedure, how to install it, how to clone this particular repository, and how to set up the environment, and how to run this particular app is all provided here. And how to upload all the data plus overall technical details, all the technical details for this particular projects, those are available in this particular Git repository for everybody to see. And how to handle the data and the file structure, so each file, what does it do, what it handles, is all provided here. And most important thing, this whole app is developed with the help of Cursor IDE. It is generative AI tools for the code generation process. Thank you.